Hi, Math 3. I'm going to do a couple problems to help you review for your mid-year, and hopefully those will help make sense of some of the probability questions, and as well as vectors and maybe some inverse functions also. Okay, so the first set on that sheet where Miss Yam had 5 red apples, 4 green, and 1 golden, right? So 5 red, 4 green, and 1 golden. Okay, so we're going to run through those problems, and I'll try to explain my thought process for each of them. Okay, so the first problem is the probability that Miss Yam picks a single green apple, right? And this one's kind of easy, right? Well, there are 4 green out of 10 total, right? So 4/10 or 2/5, right? Again, these are going to be in probably multiple choice form, right? So you can see either of these answers, right? This one is obviously simpler. So we'll go with that, okay? B is what's the probability that Miss Yam picks 2 green apples in a row if she does not replace the first apple she picks. So we already know that the first time she picks an apple, right, now that's 4/10 the chance that it's green, right, or 2/5. We'll simplify it later. And then the second time around, she hasn't replaced it. So she's holding the green apple in her other hand, right? And so there would be 3 green apples left out of the 9 remaining, because again, one of the apples has been removed. So, right, this means that Miss Yam would have a smaller chance of picking a green apple the second time, right? So this could simplify to be 2/5 times 1/3, or 1/15. And remember, we multiply these probabilities together when we're sort of chaining them together. Okay, so that's B, 1/15. C is what's probably she picks 2 red apples in a row if she does replace the first apple she picks. So the probability that we have red is just 5 out of 10, or 1/2. And if we do replace it, she has the same chance the second time. So this is really 1/2 times 1/2, or a fourth. Okay. And for D, what's the probability she picks all 5 red apples in a row if she does not replace each apple? So the first time through, she has a 5 out of 10. And then just like in part B, the second time, she's going to have 1 less red apple to pick, but there's 1 fewer apple in the bag, right? So she has a 4 out of 9, and then a 3 out of 8, and then a 2 out of 7, and finally a 1 out of 6 chance, because there'd be 6 apples left, and only 1 would be red. And now I'd want to multiply all of these things together. And before we do that, right, we'd want to simplify some of them, right? So I'm going to make 5/10 1/2, right? I'm going to make this 4 a 2, and this, a 1, and this 8 a 2. I'm going to now cross off these 2's. I'm going to make this 3, and this 6, just a 2 on the bottom. And I think I'm going to be left with 1/9 times 7 times 2 times 2, which is 1/63 times 4, which sounds like 252 to me. 1/252, that's the chance that we draw 5 red apples in a row. Okay, so now let's talk about E and F, because they sort of go hand in hand. So Miss Yam picks 2 apples, replacing the first one after she's picked it. What's the probability that neither apple is red? Neither apple is red, and she replaced. Well, we already calculated in part C the chance that each apple was red, and since the chance that each apple was red was 50-50, or 1/2, right? This is the same thing that they aren't red, right? So that the chance that neither apple is red is there's a 5 out of 10 chance that the first apple isn't red times a 5 out of 10 chance that the second apple isn't red. So that's 1/2 times 1/2 again, and that's a 4th. Now let's talk about F, okay? So here's where we're asking the same scenario. We want to know what's the probability that at least 1 is red. Well, I have 2 possible outcomes. 2 possible outcomes when I pick 2 apples like this. Either no reds or some reds, and that could be both or just 1. And they have to fall into the same category, right? So we could say that the probability of no reds plus the probability of some reds had to equal 1, right? Because all the outcomes fall into one of these categories. Okay, well, fortunately for us, this is easy to calculate, but this is hard. And since we're after this probability here of some reds, right, we're going to look to see if we can calculate the probability of no reds and do 1 minus that, right? Because if I subtract probability of no reds from both sides, right, I'll get probability of some reds equals 1 minus the probability of no reds. Well, the probability of no reds, fortunately, we calculated up here, right? That was the probability that neither apple was red. So I'll get 1 minus a fourth equals this probability, which is 3 over 4. And that's sort of my answer. All right. That's problem 1. Let's talk about problem 2 now. Hopefully that made some sense. You can pause me any point if you want to go back and look at stuff. So I have 2 8-sided dice, numbered 1 through 8. If he rolls both dice, what's the probability that both dice have an even number on top? Well, the chance that either one is even would be a half, right? A half, because there's an even number of odds and evens on that dice, right? And so we're going to just multiply a half times a half to get a quarter, because I have a half chance at each of them being even, okay? If he rolls both dice, what's probably that the 2 dice have the same number showing on top? This is kind of tricky. A lot of you want to say it's 1/8 times 1/8, and 1 over 64. I think that's too small, okay? So I roll the first die. Pick your favorite number, whatever that is, 1 through 8, right? This is just sort of a given, right? When I roll the second die, all I have to do, all we need, is to match the first. So whatever you picked as your favorite number, 1 through 8, right? You can say, what's the chance that my second die is the same thing? Well, that's just 1 over 8, right? Say we picked this was 5, and that was our favorite number. The chance I roll a 5 on the second one is 1 over 8, and that's true no matter what I roll on the top one. Similarly, you could think about this as saying, oh, I have a 1 in 64, because 1 over 8 times 1 over 8, chance of both being 1, 1 over 64 both being 2, and so on up to 8, and then you'd have 1/64 times 8, which is, of course, 1/8. So let's talk about C. He rolls both dice again. What's the probability that at least one number greater than 6 is on top? At least one. That sounds a lot like our question from above. So this would mean that the probability of some big numbers, we're saying big is greater than 6, some big numbers plus the probability of no big numbers would have to equal 1. Fortunately, this we can calculate, right? The probability that we have no numbers greater than 6, the probability that the first one isn't greater than 6 is just 6 over 8. And then the probability that the second one isn't greater than 6 is also 6 over 8, right? So this is 3/4 times 3/4, or 9 over 16, right? So I think that this is going to be P of some big numbers plus 9 over 16 equals 1, or this thing equals 7 over 16 when you subtract 9 over 16 from both sides. Okay, lastly, I guess we have 2 more. We add a third die to the equation, and we say, what's probably the first die shows an 8 on top, but none of the others do? Well, the first die has a 1 in 8 chance of being on top, being an 8 on top, and then each subsequent one has 7 over 8, right? Because they can't be 8, but they could be anything else. So I think this is going to be 49 over 8 cubed. 8 cubed is 512, is that right? 512, yes, 512, something like that. E is asking a very similar question. It says, what's probably that exactly one of the 3 dice shows an 8 on top? Well, we've already found the probability that the first one is the only one that shows an 8 on top. And what's the probability that the second one has an 8 on top? Well, that's this thing, And what's probably the third one has an 8 on top? Is the only one with an 8 on top. That's this thing. Right? So it's going to be all of those added together. So it's really 49 over 512 times 3. Times 3, right, which is 147 over 512. I don't believe we can simplify that at all. We can't. So that's good to go. Okay, so I had some requests to talk about a couple inverse problems. I'll do that, and then maybe a vector or two, and we'll be done. Okay, so let's say I wanted to find the inverse. So find f inverse of x if f of x equals, let's do, 5/3 x minus 10. Okay, so remember, we flip x and y, and then solve for y. So I have y equals 5/3 x minus 10. We flip x and y and get something like this. Now let's solve for y. So I'm going to add 10 to both sides. And I'm going to multiply by the reciprocal. So I'm going to multiply by 3/5. 30 over 5 is just 6 equals y. Done. Or this could be f inverse of x. Okay, let's do one more with maybe a cube root or something. That could be good for us. So let's think about find g inverse if g of x is the cube root of, let's do 6 times the cube root of x plus 2 over 4. Okay, so let's flip them. So I get x equals 6 cube root of y plus 2 over 4. I'm going to divide by 6. Now that I have my radical all alone, I'm going to get rid of the radical. I'm going to do that by cubing both sides. Cubing both sides. So I'm going to be left with x cubed over 216 equals y plus 2 over 4. And now I have to sort of simplify this, right? I'm going to multiply by 4. I'm going to get 4 x cubed over 216 equals y plus 2. Or y equals 4x cubed over 216 minus 2. If you wanted to clean this up, right, 4 goes into both of these things. So this is really x cubed over 54 minus 2 equals y. That would be the inverse of that guy. All right, so those are two inverse problems. Remember they're reflected over the line y equals x. And again, we're just switching x and y. So let's talk about one last type of thing. Let's do a couple vector guys. So let's say that a is some vector, and we'll say that's, I don't know, how about 2, 4, 2, negative 4. Let's let b be, I don't know, 4, 3. Okay, so let's answer a couple questions. So one, find a unit vector in the direction of A. So again, you should pause me if you wanna do that, and then see if our answers match. So find a unit vector. Well, first we have to find the magnitude of A, and the magnitude of A is just the square root of 2 squared plus negative 4 squared, which is root 4 plus 16, root 20, which is 2 root 5. Okay, and then we want to divide by the magnitude. So this unit vector is going to be 2 over 2 root 5, comma, negative 4 over 2 root 5, which if we simplify a little bit, we'll get 1 over root 5, comma, negative 2 over root 5. If I want to rationalize the denominator, I'll get root 5 over 5, comma, negative 2 root 5 over 5. And that's that. All right, so are they perpendicular? Are they perpendicular? How do we know? Well, two ways, right? Slopes perpendicular or dot product equal to 0. Well, slope's perpendicular. The slope of A is -2, and the slope of B is 3/4. So no, they're not. The dot product of them, remember, is 2 times 4 plus -4 times 3. That, of course, is just -4. So no, because remember, this would have to be 0 for them to be a perpendicular. I encourage you to look at more vectors on the review packet. I think you'll be good with them. And good luck studying. I'll be on email tonight for at least some of the night to see if any of you have any last minute questions. Good luck.